Assalamualaikum and hello. Today we will explain about the mechanism of reaction, which is esterification reaction. First, let me introduce myself. My name is Siti Fatima binti Abdullah, 85724, and this is my group members, Nurul Hana binti Ahmad, 85366, and Meg Viviana Angelica Gomez, 84459.
First step, the protonation of the carbonyl oxygen of ethanoic acid. In the initial state, ethanoic acid contains a carbonyl group where the oxygen is relatively electron-rich. During protonation process, the acid catalyst donates a proton to the carbonyl oxygen of ethanoic acid. This protonation occurs because the oxygen's lone pair can attract and stabilize the proton, leading to the formation of a protonated carbonyl group. This protonation makes the carbonyl carbon more electrophilic, which is electron deficient, enhancing its susceptibility to nucleophilic attack. The positive charge on the oxygen creates a resonance stabilized intermediate where the positive charge can be delocalized over the carbon-oxygen bond.
Next is the second step, nucleophilic attack by ethanol. Ethanol acts as a nucleophilic due to the lone pair on its oxygen atom. The oxygen of ethanol attacks the electrophilic carbonyl carbon of the protonated acetic acid, forming a tetrahedral intermediate. This intermediate now has the carbon previous double bonded to oxygen bonded to two oxygen atoms, which is one from the original carbonyl and one from the ethanol.
Third step, formation of a good leaving group. Proton transfer. A proton from the ethanol molecule is transferred to the hydroxyl group of the intermediate. This step may be facilitated by the acid catalyst converting the hydroxyl group into a better leaving group. Resulting structure. This forms a protonated alcohol group, ozonium ion, where the oxygen is now positively charged and makes the protonated water a good leaving group. Fourth step, formation of the activated complex. Deprotonation by ethanol. The ethanol molecule can deprotonate the ozonium ion, leading to a more stable intermediate. This deprotonation transfer a proton from the ozonium ion to the ethanol, resulting in a neutral tetrahedral intermediate ozonium ion. Protonation of hydroxyl group. The hydroxyl group accepts a proton from another molecule of ethanol or the reaction medium, forming an activated complex where the OH group becomes protonated water, ready to leave as a water.
Fifth, elimination of water. In 1,2 elimination, a lone pair of electrons on the oxygen forms a double bond with the carbon, simultaneously expelling the protonated water molecule as the leaving group. In the formation of protonated ester, this elimination results in a protonated ester intermediate where the ester group is formed but is still protonated.
The sixth step is deprotonation to form the ester. The protonated ester undergoes deprotonation, facilitated by the solvent or another base in the reaction mixture to yield the natural ester. The final product is ether ethanoate along with the regeneration of the acid catalyst.
This is the final product for the mechanism of reaction, which is ethyl ethanoate.